Today we're going to factor ax squared plus bx plus c. Now it's important to remember in this case we're looking at when a is 1. So what we're really factoring is just x squared plus bx plus c. So there's two things I'd like you to think about when you factor. Number one, you need to find two numbers that are integers, m and n, such that the following two conditions are met. M times n has to equal c, and m plus n has to equal b. Once you meet these two conditions, you go to the second step. You write the two binomial factors, x plus m times the quantity x plus n. Okay? So everything's in twos. Two integers, m and n. Meet these two conditions, and we write two binomial factors. So this is going to be the background of our whole lecture today. So let's look at some examples of factoring these types of quadratics. Now, the first example is factor the expression. We lost an n there, it looks like, when I put the slides up. So let's factor the expression x squared minus 9x plus 20. So, no common term to all three of those, so I can't factor anything out. So let's look at finding two integers, m and n, that multiply to be 20 and add to be negative 9. So I know 5 and 4 add to be 9, and they also multiply to be 20, but I have to be very careful. I know that if both 5 and 4 are negative, I get a 20 as a product. So negative 5 times negative 4 is 20. Those same two integers, negative 5 plus negative 4, add to be negative 9. So I've met my conditions. So I write, in step 2, I write my two binomials, x minus 5 times x minus 4. So I've done the factoring. Now, not all quadratics are factorable. And later on we'll learn, when we talk about the zeros and the x-intercepts, just because you can't factor a quadratic doesn't mean the zeros don't exist. So in part B we have x squared plus 2x minus 12. So I'm looking for two numbers whose product is negative 12, whose sum is 2. That's not possible. I think of the factors of 12. 12 and 1, 6 and 2, 4 and 3. None of those add to be 2. So I can't factor this. So we say this is not possible, or we say it's not factorable. So I wanted to show you real early on that not everything is factorable, and that's okay. In these two examples, I've kind of switched the variables and letting you know that you don't always have to use x. Okay? So in the first one, again, we're factoring this expression, no common terms. So we're looking for two integers whose product is 22 and whose sum is negative 13. Well, 22, only 11 times 2. Okay? 11 plus 2 gives me 13, and 11 times 2 gives me 22. So let's look at changing the signs. If both numbers are negative, negative 11 times negative 2, I get 22. Negative 11 plus negative 2 is negative 13. So I've satisfied my two conditions. Writing the binomials, a minus 11, that quantity times the quantity a minus 2. And those are my factors. Now, in part B, I've actually given the variable m. So when I'm looking for my two integers, I just gave them a new name. I call them p and q. Okay? They're just variables, so you can let them be anything. You can let them be a and b, t and z, doesn't matter. So I need two integers here that multiply to be negative 65 and add to be 8. With some trial and error, I get 13 and 5, it gives me 65, but I have to have the right combination of signs. 13 times negative 5 gives me negative 65, and 13 plus negative 5 gives me 8. So I've got my m and n, or in this case my p and q. So I have the quantity m plus 13 times the quantity m minus 5. Now, you can't talk about factoring quadratics without talking about solving quadratics. And when we solve quadratics, we've got to talk about the zero product property. The property is simple. It says if you multiply two numbers together and they have a product of 0, one of those numbers has to be 0. And that's what we get here. The product is 0. If you multiply two numbers, one of them has to be 0, or both. But they both could be 0. But a times b equals 0. Then one of them has to be 0. So how does this apply to quadratics? Well, I put an equation. I said x squared minus x minus 42 equals 0. So this zero product property is going to come into play when we solve equations, solve quadratics. So I just start by factoring the left side, and I get x minus 7 times the quantity x plus 6, and that equals 0. So I have two numbers being multiplied whose product is 0. One of them has to be 0. So I solve each binomial. I get x plus 7, or x equals 7 here, and x equals negative 6 here, and we see our zeros. Okay? Now this is very important. When you look at this equation, basically we're finding the x-intercepts, the roots, the zeros. So let's look at a couple more examples. So, in this example, we're looking to find the roots of this equation. Now the roots are the x-intercepts. They're the zeros. Okay, they're the solutions. We've set y equal to 0, so you are looking for the x-intercepts here. And we start by factoring. So we begin by factoring. Two numbers that multiply to be negative 36 and add to be minus 5. Here's my two conditions, negative 9 and 4. Negative 9 times 4 is negative 36. Don't forget that negative there. And negative 9 plus negative 9 plus 4 is negative 5. So those are my two conditions. There's my factors. And they equal 0. So that means one of those two numbers has to be 0. So x equals 9 or x equals negative 4. Those are my roots, my zeros, my x-intercepts. Those all mean the same thing. Okay, and this just goes back to the example we repeated earlier. X squared minus x minus 42. And I just wanted to kind of reiterate this because I didn't really show the example. I just wrote it out real quickly. But solving means to find the x-intercepts, roots, zeros, etc. So I just really wanted to bring that home with an example we've already talked about. And then, here are the conditions. Here we want this to be m times n to be negative 42, okay, and that m plus n to be negative 1. And again, when you have two numbers that are multiplying to be 0, one of those numbers has to be 0. So you have to solve each of those binomials for x. And that's really the zero product property. So we're taking factoring, adding the zero product property, and taking that one step further by solving. And there's other ways to solve quadratics that we're going to learn throughout the unit. I'm sure you've heard of quadratic formula. We're going to talk about completing the square. We can solve by graphing. So this is just a basic introduction to factoring x squared plus bx plus c when a equals 1. We're going to look at when a is not 1 in the next lecture. So if you guys have any questions, just email me or type in the comment box below, and I hope this helps. We'll see you next time.